everybody, this is Jesse Rogers, and I've got a pretty challenging problem here to work on today. We're finding the second derivative, and we're doing it using implicit differentiation. So let's go ahead and get started. We've got, as you can see, 2y squared minus xy plus 3x squared equals 4, and this middle piece is going to require us to use the product rule because it's two variables being multiplied times one another. So we're going to have to apply the product rule for that. But otherwise, it shouldn't be too bad for the first derivative. So let's go ahead and see what we get. So for the first derivative, what we're going to do is we're going to multiply the 2 times the 2 out front, and that's going to give us 4y to the 2 minus 1 times the derivative of y. And the derivative of y, if you'll recall, like let's go back to something like y equals x to the fourth. Now, what's the derivative of y equals x to the fourth? You'll probably say 4x, right? 4x to the third power. That's what usually comes to people's mind because that's what you're usually working on. But with implicit differentiation, you're also being mindful of what's going on the other side. Usually they have this part filled in for you, but it's dy dx equals 4x cubed. It's not just y anymore, it's y prime, or dy dx. This is what y prime means. So if you are taking the derivative of a y, the moral of the story is it is not 1. It's equal to y prime, or it's equal to dy dx. Now you're actually applying the chain rule here, because when you take the derivative of x, well, what is the derivative of an x? It's going to be dx with respect to x. So you have the same thing on the top and the bottom, and so they cancel out. So you never notice it, but you've been doing that the whole time in the background. It just happens to be that when you take the derivative of a variable and with respect to that variable, it cancels out and becomes 1. So most of your experience with taking derivatives has been on the right side of the equation. That's where your focus has been. But I just want to make the point that this is what's happening behind the scenes, and this is what's happening on the left side of the equation. Okay, so let's go back to this. Where that gets us to is that the derivative of y is going to be dy, and this is with respect to x, so it's dx. That's what's on the denominator, is whatever variable we're taking with the derivative with respect to. And so we're going to have to use the product rule for that middle term, and I'm going to do that off to the side here again too. So the product rule, I'm going to use f and g. So I'm going to define f as being negative x, and I'm going to define g as being y. So the derivative of f is going to be negative 1. The derivative of g, as we just talked about, is going to be dy dx. So I am going to go ahead and do the product rule. So remember, the product rule is going to be f g prime plus the other way around. And you can switch the order around. I don't know which way the book shows or which way. I just remember it's got to be one of each plus the other way around. Order doesn't really matter here because we're talking about addition. It does matter for the product rule. I mean, for the quotient rule. So that we do have to be a lot more careful of. But if this doesn't match exactly what you have in your book for the product rule, that's okay. It's, it doesn't really matter which way you have it oriented. But anyway, so we're going to multiply the f, which is negative x, times the g prime, which is going to be dy over dx, plus the g, which is y, times f prime, which is a negative 1. And this is going to give us our product. I'll just leave it like that. So this is going to get plugged in right up here. So we're going to have minus That's the derivative of this part, right? So this is going to be minus x dy dx minus y. And then what's the derivative of 3x squared? That's going to be 6x. What's the derivative of a constant? It's 0. All right, I'm going to get rid of all this work on the side. Hopefully you've got all of this copied down already. So let's go ahead and make ourselves a little bit of room over here on this side. And what we're going to need to do next is solve for dy dx. My approach to that is that I'm going to subtract or add anything that doesn't have the dy dx as part of its term over to the other side. So this is going to be plus y minus 6x. I need those over on the other side. So I'm adding y and I'm subtracting 6x from both sides so that they cancel out and go over to the other side. And I'm going to have 4y to the first dy over dx minus x dy over dx equals y minus 6x. Now I've got to notice that I actually have my dy dx as a factor of both of these terms. And so I can factor this out the same way as I would factor it out if they had a common factor of 3 or a common factor of x squared or something like that. I can factor out whatever they have in common. And so I'm factoring out a dy dx, which leaves me with, in the parentheses or in the brackets, whatever you want to use, 4y minus x. And to finish this out, I'm just trying to get the dy dx by itself. So to solve for that, I am going to divide here by, what am I doing? I'm getting too caught up in how I'm making my 4s. Okay, 4y minus x. And those will cancel out. We've now solved it where dy dx is equal to y minus 6x over 4y minus x. Okay, so I've taken the derivative of, or the first derivative of the equation, and now we're trying to find the second derivative. So what I'm going to have to do is do the quotient rule, because now I have a term being divided by another term. And so I'm going to define f as being y minus 6x. I'm going to define g as being 4y minus x. So I take the derivative of each of these, and I'm going to get dy dx minus 6. And the derivative of g is going to be 4 dy dx minus 1. All right, so with the quotient rule, it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. And so I'm just going to plug in all of these values here. So that's going to be 4y minus 1, I'm sorry, 4y minus x, that's the g, and then the f prime is dy dx minus 6 minus f, which is y minus 6x, and g prime, which is 4 dx dy dx minus 1. And this is all divided by g squared. So we have 4y minus x squared. All right, so there's a lot going on here. It doesn't really look like there's going to be anything that we can factor out. So instead, what we're going to end up doing is we're going to have to FOIL these. So let's go ahead and make some room. Okay, so we're going to FOIL the first two binomials here. This will be 4y minus x times dy over dx minus 6. And then I guess I'll do the same thing over here with the I should probably be able to fit it all on one line. And I'm going to leave off the denominator for a little bit just to not have to keep writing it over and over again. We know it's there, but I'm just going to focus in on these off to the side. I'm going to focus on these binomials. All right, so the first thing I'm going to do is multiply 4y times dy dx. So that's going to give me 4y dy dx. Then 4y times negative 6 is going to give me negative 24y. Negative x times dy dx. It's going to give me negative x dy dx. And negative x times negative 6 is going to give me plus 6x. And then I'm going to do the same thing over on this side. So the minus I'm going to just bring down, actually, and I'm going to keep this one in parentheses because I know that the negative has to distribute to all those. But I'll handle that in a second. So the y is going to multiply times the 4 dy dx and give us 4y dy dx. The y is going to multiply times the 1, give us minus y. And we're going to have minus 24x dy dx. And negative 6x times negative 1 is going to give us plus 6x. So I've got to distribute the negative, and that's going to give me all of these terms. They're just going to flip the signs. And I'll rewrite this line just to keep it all on the same line. Just bring these down. Okay, so I notice that I've got some terms that should be able to cancel. So I have a 6x right here that's positive. I have a 6x right here that's negative. Those can cancel out. I have a 4y dy dx that's negative over here, and I have a 4y dy dx over here. Those can cancel out. I have a, let's see, it looks like there's a y right here, and I have a minus 24y, so that can combine and give us negative 23y. And I have a negative x dy dx, and I have a positive 24x dy dx. So this and this can combine and give me a plus 23x dy dx. Okay, now remember that this was all being divided by the we had dealt with the numerator, so it's just the denominator squared that's on the bottom. And we go ahead and enter that in, and it tells us that that's the wrong answer. And the reason why is because it's going to want us to replace this piece right here, this dy dx, with what we know dy dx is equal to. So we have to go back, and instead of entering this in as what the second derivative is, because remember, we were trying all this time, we were trying to find the second derivative, and it's equal to this. But remember, we can't have the derivative in there. We've got to get rid of that dy dx, and the way we're going to do it is by substitution. We're going to replace that dy dx with what we know that it is equal to, which is this y minus 6x over 4y minus x. And so now that is our result. That's our equation. Now you could probably clean this up further using algebra, but I would not do it. I would leave it exactly like that, because we're doing this on Pearson My Math Lab. That's where I got this problem, was helping a student that was using Pearson My Math Lab, and it does accept it like that. So I would leave it just like that and not do any extra algebra that might give you the wrong answer if you make a mistake. So that is a pretty challenging problem. It took us a few pages worth of calculations. It took us some foiling, factoring. So there was quite a lot in there. We had to use the product rule, the quotient rule, the chain rule, and so don't be frustrated if if you found that problem challenging, because that's incorporating quite a lot of techniques all into one problem. But if you did follow along, then excellent. And if not, you may want to go back, rewind this, watch it or parts of it a couple more times until that makes sense to you. Thanks for watching, and if you have any comments for me or any questions you want me to work out, leave them in the comments below, and I'll see you next time.